All right, so today we're going to start with our probability section, and we're going to talk a little bit about what probability means. But we're also going to focus on what's called experimental probability, okay? And we're going to look through some terms and definitions. Now, the terms and definitions will allow you to be able to follow along, so it's really important that you write those down and you know the terms and definitions that we use. For if I use a word that's specific to probability, you need to know it, otherwise you're not going to know what you're supposed to be doing, right? And again, this is probably a topic that you've experienced before, and so some of you are going to be thinking, right, it's kind of dull to do stuff that you already know how to do, but just think of it as just to get you back into schoolwork and get you into learning how to do notes and how we're going to run the class, if that's the case, okay? If probability is new or has ever been an issue with you, then fine, you're going to get a full lesson on it. One thing I will caution you about, most of you will be continuing on in your math career, right? And statistics is going to be a big part of that. And probability is one of the basic facts of statistics. And as such, it is critical that you understand how it works, right? So even though these problems might seem a little simple now, it'll build, right? You always want to start off easy. So what we're going to do is flip over to Education Perfect and look at their lesson. Okay, so when you enter Education Perfect, you're going to see all of your classes. You'll also see some tabs at the top. Now, they may look a little different than the ones I have because mine is the instructor version, but some of them are the same. QMC has purchased full access to all levels of the mathematics that are available on Education Perfect. So some of you may have some questions about material that as we move forward in this class that you might need a little refresher on, right? Some of you are going to be sailing on ahead and want to work on more difficult material, right? Well, we've got you covered. And here's how that's going to happen. If you go to the content library, right, you'll see maths, and of course you'll have other topics as well. Here are all the topics that are available. Now, we're working in statistics because we're doing probability, okay? And we're going to be working on probability. And you'll see that probability has many different levels. And so as long as you stay with probability, if you want to work further and do more difficult questions with probability, this is where you'll do it, okay? It'll use the same basic facts, it's just extension, right? Now, I'm not going to assign specific assignments for review class level extension, right? But it's there for you. If you want me to make an assignment for an extension assignment, we can. I can do that. That's no big deal. But if you want extension, it's here. What I don't want you to do is pop into different areas, right? I want you to stay on topic. So you'll have your regular assignment that I want everybody to do, okay? But then you can go backwards if you want some clarification. You can go forward if you want extension. Everybody see that? Now, you don't have to stay with, this is the middle years program. Some of you may be more advanced and might want to look at probability and statistics from one of the NCEA levels. So depending on where you are, okay, you work as far forward as you'd like, and I'm happy to help you at working with those. And again, you're going to see, what I want you to see is that the basic ideas just get bigger, and you add things to it, the types of things you do, okay? Everybody okay with that? But normally, you're just going to go to your class, and your class is the Year 9 Maths with my name on it. Should pop up for you. Okay. All right. Pause that. Okay, so you don't have to go through the content library to get to your assignment. Your assignments will be posted under your class. When you're doing the assignments, you're going to see a couple of different symbols. Most of you have done Education Perfect before. The eyes, the yellow eyes, that's information. That's the stuff we will have covered in class. That's kind of the lesson. So don't worry about those when you're doing your homework unless you need to refer back to something. But you'll also have that in your notes too. So I would prefer you use your written notes than go back. But there are some things in there that you might want to read through or watch. Okay? So this is the stuff that we'll go through together in class. Then you're going to see the purple. That's the homework questions. We'll do some of those if there aren't enough questions in the information sections. We may do some of these together in class, just so that I can make sure that you've seen everything and we've done an example of everything that we need to. Okay, so then you'll see here's experimental probability. We're going to do both of those lessons today, and then there's some homework questions. I'm going to stick with the default for Education Perfect, which is it's due 7 days after it's assigned, and then you get 7 more days, but it's late, and it tells me that you haven't done it. 7 days is too long, because what we do today, we're going to use when? Our next meeting, right? So don't put it off even though you have 7 days, but things happen. Also, if you're struggling with an assignment, do what you can, give it a shot, okay? Here's what I want you to do. Do the first one. If you're fine with it, perfect, move forward. If you do the first one and you get the wrong answer, then it'll tell you and give you a new question, or else it'll give you several chances on the first question, and then it'll give you a new question. Then what you need to do is you need to use your notes, ask me, ask a friend, whatever, and find out why your answer is not correct, and then correct it. Okay? If it doesn't work, I don't want you moving on and just trying every problem. That's not good. Anybody play music here? Play an instrument? Yeah, several of you? Okay. So let's say I'm going to learn how to play the piano. So what I'm going to do is I'm going to put the sheet music in front of me, and I'm going to play the song in front of me. Well, how likely is it that I'm going to do well the first try if I've never done it before? Not very likely, right? So here's what I'm going to do. What I'm going to do is I'm going to take that sheet music and I'm going to throw it away and get a new song, because it's clearly the song, right? It's not me.
Yes, definitely.
You're right, yeah. So don't think of it in math that way. You don't need to do more problems if you're not understanding. You need to do the same problem over and over until you understand it. Then you can move forward. All right? I don't know where we get this idea that we can do more problems, different problems, whatever, and it's going to make it better. That's not true. You do the same problem over and over again until you know what it is you're doing. Okay? Right? And then you can move on to just new problems. Is that a concept that's new to you? Hopefully not, but usually it is. So don't do more work. Work smarter. Right? Make sure you're understanding what you do before you move forward. Okay? So I just gave you permission to quit doing your homework until you talk to me. Right? You need, my job here is to get you to understand what's going on. Okay. So let's look at the probability. Now, one of the reasons about that Education Perfect, but it gets better in year 9 for you. One of the things I don't like about Education Perfect is their need to put a kitten on every screen. But, little kitten isn't going to hurt anything. So it gets a little less cutesy as we move forward. But there's still going to be things. But you know what? If it gets a smile out of y'all, it's okay. It's worth it. Okay. So we're going to talk about probability. And again, they're going to give you some of these. I'm going to tell you what I think you need to write down. Right? So let's talk a little bit about probability. The word probability represents the chance of an event occurring. Okay? So, hold on just a second. Okay, so probability simply means the chance of an event occurring. And many people confuse this with odds. It's not really the same thing. Okay? So probability is the chance of an event occurring. And all probabilities, so you should have probability, and then is the chance of an event occurring. Something like that. Okay? You can use whatever term you like. Okay. Now, every probability is always a number from 0 to 1. So if you get a probability that's 2, what can you conclude? You've done something. Yeah, you've done something terribly wrong, right? Okay, so all probability happens between 0 and 1. With 0 and 1 being very specific parts of probability. If you get a probability of 0, that means that event is actually impossible. And so that's what they give you here with this. A person being able to lift an airplane is definitely impossible. So what is the probability that you're going to lift an airplane today or any other day? 0. Okay? Now, a probability of 1 is a certain event. Certain meaning that it's going to happen no matter what you do. Okay?
That sounds threatening.
No, it's not threatening. So, for example, will you have a birthday this year? Absolutely. You're going to have a birth date. Your birth date will occur, right? Everyone in this room was born between January 1st and December 25th. There's no other possibilities.
What if you die before your birthday?
It still happens. The day still occurs, right? Okay? So, all right. So, March the 3rd will occur every year. What is the probability of March the 3rd occurring? 1, right? It's definitely going to happen. Everybody agree?
The world ends before that.
Oh, you guys, come on. The world can't end yet. I just bought a new bike. Okay, so the probability of something happening can be never, or it can be a certain thing. So there's your cat. Get used to it. Lots of them. Okay. Dogs. My favorite are the sloths, but they stopped doing that at like level 4, sadly. Okay. All right. So
we saw a dinosaur. It was
there,
cute.
lots of pardon.
We saw a dinosaur and it was really cute. It was just walking, and then we saved it to the laptop, and you can make it go faster. So like running.
You have to show me how to do that. Okay. So another thing about probabilities that you need to know is there are different formats for probabilities. You can write probabilities. So here's what should be in your notes. Probabilities can be written as fractions, decimals, or percentages. Which means that you, as a student, need to know how to work with fractions, decimals, and what? Percentages. You betcha. And we will review those topics as we go. I'm never going to just say, okay, everybody knows how to multiply fractions, right? You might know, some other people might not, all right? So I'm not going to assume, right? Now, I may refer you to a way to do it or refer you to a lesson or something like that, but I'm going to be there for you, okay? So don't think about it. So what we're going to do is we're going to look at some different probabilities and talk a little bit about what's called experimental probability in just a moment, okay? So here we go. Let's look at some probabilities. There we go. All right. So here's our example. Classic example, you're going to flip a coin, okay? Now, if you flip a coin, how many sides are there on a coin? 2. One side is heads, the other side is tails, right? Okay? So how many possible outcomes are there if you flip a coin?
Unless the line's not signed
2.
perfectly. 2.
That's never going to happen, okay?
Don't say me that.
Yeah, it ain't going to happen. So, when you flip a coin, a proper coin that's not doctored and landing in glue or whatever, You're going to get either heads or tails. It's going to flip on one side or the other. Do you agree? So you can either get a heads or a tails. Can I get a heads and a tails at the same time in just one flip?
No.
Absolutely not. So that makes getting both of them impossible, which means a probability of 0. Okay? Now, listen to this question closely. If I flip a coin, will I get a heads or a tails?
Yeah.
Absolutely, which means the probability of that happening is 1. It's certain. Okay? But usually, right, you're going to get one outcome out of this particular thing. So, when you flip a coin, sorry, I was trying to scroll on that. There are a total of 2 equally likely possible outcomes. And that's a hugely important concept when we're talking about probability. The only way you can measure probability is if things are equally likely to happen. So that's very important to you. You might want to pop that into your notes. In other words, we can't measure probability if one of the choices that we're given is not going to happen. Okay? If I give you a tray of candy and it's all pineapple lumps, I'm impressed that I know that. If it's all pineapple lumps, what can you pull a Snickers out of there? No.
Well,
So right? Okay, so you've got to make sure that that the things that you're measuring are equally likely. Okay? Because otherwise it changes the probability to 0. You betcha. There you go. Yes.
So say, what is the difference between odds and probability? So say you put sweets in front of me, what are the odds that I instead of not?
Okay, odds is a different concept. Odds is the probability that you will do something divided by the probability that you won't. And we'll look at odds later. And people do often think of probability and odds of being the same thing, but it's really not. Odds is a ratio, which means a fraction of between how likely it is to happen versus how likely it is not to happen. Okay?
And probability is equally likely, so everything has to be equal.
And probability is just how likely something is to happen. And I know it doesn't, but we'll look at odds and it'll clarify that. Okay? But so probability and odds are not the same thing. Yes?
Probability cannot be measured unless in terms of if you have multiple factors, but only one of them has any chance of happening.
Well, yeah. Well, what are you going to get? What's going to happen if one of them has no chance of happening? Then that automatically turns the probability to what? 0. So it's an impossible event. So there's no way to get another measurement for it. It's just going to be 0. Yes. So your question is exactly correct. Yes.
So what if it's like slightly likely, but the other one's more likely?
Doesn't matter. Nothing is more likely to happen if you do it. So let's say you have a big bucket with 100 balls in it, and they're all different colors, and there's only one red one. When you dump your hand into that bucket, if you're not looking, right, you're just as likely to pull out that red ball as any other, right? Because when you're reaching down there and looking and just grabbing a ball, could you grab the red ball? Yeah. Now, the probability of grabbing it might be higher or lower, depending on how many red balls there are there. But it's still just as you're just as likely to pull that red ball as you are to pull any other ball. Okay? Doesn't seem right, but it's true. All right. Now, the odds are off, but probability is what we're talking about. Yeah? See, that's where the difference comes in. The odds are 2 probabilities, and but we're talking probability, not odds.
Probability is like it still can happen.
Yes, because if it can't happen, the probability can be measured, but it's always 0. Now, probabilities can be written as a fraction, decimal, or a percentage. So, when you flip that coin, you're going to get either a heads or a what? So, how many possibilities is that? You have 2 possibilities, but you're only going to get how many of them? 1. And so the probability of heads can be written in 3 different ways. 1 over 2 or 1 out of 2, right? You can change that fraction into a decimal, 0.5, or you can change it to a percent, 50%, right? All of those things are equivalent, and hopefully you know how to convert back and forth from one to the other. If not, we'll talk about that, right? Everybody brought your calculators too, right? Because your calculator will do that for you. Good. Okay, so
So we have to write that. Do we write that down?
yes, right. So the probability of heads is 1/2 or 0.15 or 50%. Okay? And that's not really an example. That's just a... Okay? Now,
Wait, what? What was it?
It's 1/5.
oh, sorry. It's 1 over 2
Oh, is it?
equals 0.5 equals 50%. Because those 3 things are equivalents. Okay. So here is a more formal definition of what we're really doing and how we got what we got, as well as some notation that you need to have. Okay? So we'll look at this side first. You see the big P stands for, what do you think? Probability. And if you have a bracket, which I call parentheses, so you're going to have to deal with it, because I'm going to go back and forth, because that's parentheses to me in the States. That's a bracket. So, sorry, I will try to say bracket. I'm never going to not try. So, if you have a parentheses, what operation does it mean if something is right up against a parentheses with no symbol between? Multiply. Excellent. Okay? And does anybody remember the key word that always means multiply? That word in English that always means multiply? And I'm just going to write it so we don't have to worry about it. Of. If you ever see the word of in a problem, that means stick a multiplication symbol there. So, this is literally saying, and in this case we have A. We name events, okay? An event simply means what happens, okay? The probability of what we want, okay? So this is read as the probability of A. And A can be anything. Flipping a coin, the probability that you're going to sit at that particular table in a group, the probability that it's going to get way too hot in this room today. Then, you see what I'm saying? So it can be any event. So it's not restricted. Any event can be probability. But because it's because it's right in front of it, that really means multiply, which gives you that word of. So this part is read as the probability of blank. Now they're using just capital A to stand for any event. Capital A, any event, right? But when you're writing it and doing a specific experiment, it needs to be very specific. So for example, if I want the probability of getting a heads, then I'm not going to write probability of A. I want to be specific. You can, depending on who you are, write out the whole thing. Right? But whatever you're measuring, whatever you're looking for the probability of, needs to go in the parentheses. And you have to have the P in front. Sounds good? All right. And this gives you the formula that you're going to use for what's called experimental probability. They also use it for theoretical probability too. So what we're going to do is this gives you where you're going to put your numbers. So on top, it's the number of correct or favorable outcomes. So a while ago, I was flipping a coin. If I want to get a heads, how many heads are there on a coin?
1.
So how many favorable outcomes are there?
1.
Just one, right? Favorable outcomes, right? Because I want the heads to happen. Okay. What if I wanted a tails? It's 1 again, yeah? Okay. Now, sometimes they're the same, not always. Okay. And the bottom of the fraction is going to be the total of outcomes possible. So how many sides are there to a coin? 2. So I'm going to get one or the other. So that's where that 2 came from on the bottom. All right? So you must know that definition of how the probability is built. The one you want goes where? On top. How many there are, all possible ones, goes on the bottom. Make sure you know which order to put them in. If you put them in the wrong order, then your probability is out the window. Because let's say we reverse them. Probability of a heads as 2 over 1, which is 2. We know that's not right. Why? It can only be between 0 and 1, right? So at least, in that one at least, you would have some clue as to why that can't happen. But you can't always count on that. Okay? So, favorable outcomes goes on the top. All possible outcomes goes where? On the bottom. What's the top of a fraction called? Anybody remember? Numerator. What's the bottom called? Denominator. Good. Not particularly relevant to this class, but I like to make sure that everybody knows what's going on. So here we go. Here's our example. We're going to do this one as a class, right? All together. So this is not going to be one where I'm going to have you work on it. We're just going to work on this one together. There's some more in there. So we're going to find the probability of rolling a 4 or more on a regular 6-sided die. Now, you've got to be careful and read carefully, right? Understanding is the biggest key here. First of all, we're working with a die. So what we want is the probability of a 4 or what? More. So can I have a 4? 4 is perfectly fine in this situation, right? It says 4 or more. What if it said a number greater than 4? Would I include the 4? No. So be careful when you're reading that. So a 4 is okay. What are the other 2 numbers on a die that are okay? 5 and 6. So what I'm looking for is the probability of getting either a 4, a 5, or a 6. Any of those I'd be happy with. Okay? Now there's another way of writing that if you want. The probability that you roll something that is greater than or equal to a 4. Do you remember this notation for inequalities?
Alligator eats.
Okay. Alligator eats the bigger one, you betcha. So, you want to roll something equal to or bigger than a 4? I'm fine with either one. If you want to list them, that's perfect. Only 3 numbers to list. What if there are 200 numbers to list? Then we want to use the symbolism. Okay, so you should be prepared for both. All right, but either one of those is a way of writing it. Okay, you might also see it using an X. So all of you have been exposed to algebra. You know that X just stands for any number, right? As X has to be bigger than or equal to 4. Any of those notations are fine. What you can't do is just write something like greater than or equal to 4. Because it really doesn't give you the right information. And inequality really needs both pieces. Okay? Is it driving you crazy that I'm writing in red? Okay. I can change the color. Y'all can, if y'all have a favorite, just tell me what color y'all want. Okay, now, so what we need to do is we need to find out how many favorable outcomes there are on that dice. Well, there's how many 4s?
1.
How many 5s?
1.
How many 6s?
1.
So how many numbers is that?
3.
So there are 3 favorable outcomes. It's just a matter of counting. Okay? Now, on the bottom, we need to know, right? Because remember, it's always the number of favorable outcomes, the ones we want, over how many there are, the total number of how many there are. How many number sides are there on a die?
6.
6, right? So there we are. So our answer is 3 over 6.
What? What do we have? Do we have to have it? What are we doing?
What is the golden rule for all fractions?
Simplify.
Simplify if you can. Which means you try to divide it out, but 3 won't divide evenly by 6, but they'll both divide by what? 3. And if you divide them both by 3, sorry, I'm writing across your picture, you get 1 over what?
2.
2.
Which is 50% and
Okay.
0.5.
which is 0.5 or 50%.
So what do we write in our note?
I'm perfectly, 1/2 would be, that is generally the preferred way of writing it, okay? Now, if you were explaining this or using it in a paper probability, then you might write it as a percent. 50% of the people who did this or whatever, that's how you write statistics usually if you're writing it as an explanation. But if you're just doing the math, we typically use a fraction. Make sense? Look easy?
Yep.
Because it is, right? But you need to make sure to be careful. Because how much attention do you pay to something that's easy? Not very much. And then what happens later when you have to do it again? You forget because you didn't study it because it was too easy. So be careful. Easy is the one that kicks you in math. Because you spend your time focusing on the stuff that you think is really, really hard, and then you don't know the background of the pieces that you need to make it work. Okay? So be careful. Don't fall into that trap. Some of you are going to be fine. Others of you are going to make that mistake. Okay? All right, here we go. We're going to do this one. You're going to do this one.
Yay.
All right? So get ready. So this goes down with your example. I know we don't have any steps for this, but remember where you wrote down the definition? Probability of A equals the favorable over all of them? That's pretty much the steps. Yes?
So we always write the question and then the answer?
You don't have to write down the whole question. No.
Okay.
But you can write down the probability part of it. So let's do label some steps. We didn't do that. First thing, you're going to determine, what do I want to happen? Right? You got to start with what you want to happen. Okay? And that becomes your numerator. I am going to use math words. Imagine that. Because I expect you to be able to know the language of mathematics. But numerator simply means which number? The one on the top. Okay? Second. Okay? How many possibilities are there? So these are the two questions you need to ask yourself. And that becomes your, what's it called? Denominator. Thank you very much. And you guys don't need to raise your hands for this kind of thing. Just sing out, okay? Act as a class is fine. So the denominator, okay? And third, you must, I don't usually use, simplify. Which means that 3/6 is not 3/6. 3/6 is what? 1/2. Okay? And use the proper form. Now, what I mean by using the proper form is, if it tells you it wants a percentage, then don't write it as a fraction or it's wrong, right? So make sure you're using the proper form. And that's all there is to it. So now we have a series of steps. Let's do our example next to it. It's example 3. Bjorn buys 20 rubber ducks for a duck race charity fundraiser. There are 250 ducks sold in total. So they've got this big barrel of 250 ducks, and he buys how many of them? 20. Find the probability that they're going to select one of his ducks. Go. Let's do it real quick, Paula. Okay? All right, who has it? Okay, so how many ducks did he buy?
20.
So we want the probability of one of Bjorn's ducks. Okay, I'm just going to put probability of B. You can put probability of duck or whatever, but specifically his ducks. How many did he buy?
20.
And how many were there?
250.
2 out of 250 total ducks. And that's my answer, right?
No.
No. Right, if they've got a 0, you know that those zeros can divide away. So 2 out of 25, which you could then turn into a decimal if they wanted you to, but a fraction is perfect. Or you can turn it into a percentage, but a fraction is perfect unless they ask for something different. Okay? Guess what we didn't do, guys?
Roll.
So hold on, give me a minute.